Hi everyone, this is the second class in mechatronics subject and the topic is actuation system, and this is one of the important topic for both ESC as well as for interview purpose also. So in this particular section I will explain you about what is the actuation system, what are all the components included in the actuation system, as well as what is the significance of each and every element, how each and every element participates in the actuation system. So, and one more thing I want to tell you guys before starting, this particular topic is useful for both mechanical students as well as for instrumentation students also. Come, let's get started now. As I said, in today's session, we will discuss about what is actuation system and why we require actuation system. So before going into the topic deeply, first let me clear you what is actuation system by taking a simple and normal example. Suppose, let us say we have a load here, and for time being, let's consider that the weight of this load, maybe it is equal to 20 newtons. Let us consider that this is 20 newton weight. Now, if you are here, exactly here at this location, let us take that this is you, and you are interested to displace this particular load linearly by some amount of distance. Maybe let us assume that it might be around 0.5 meter. You want to displace this particular load. Now tell me how the human body functions in this particular task. The first thing is you are almost away from the load. So first you need to reach up to the load, and the second thing is you need to push the load, right? So two things should happen here. First you need to reach to the load, and the second thing is you need to push the load. Two things should be happen. Now tell me how the human body reacts to this particular task. So if you vaguely discuss this particular concept, first you need to start from blood. Suppose let us say, I'm not going to get into the details of human body here too much, because this is not biology class, rather this is a mechatronics class. So blood, assume that there is some amount of the blood in the human body. First this blood goes to any of the purifier, that is in human body what are all the different organs which purifies the blood. It might be like you can take, of course, at different stages different organs will going to purify the blood, right? So let me take in the first case here, like first organ you can consider like kidney, and sometimes liver also, not sometimes, in most of the situations liver also, right? So the blood will go to these organs first, and it gets purified. Once it is purified, the blood will go to heart. Now heart will going to pump the blood, then this blood transfer to different organs, right? So different organs means you can consider here legs and maybe hands, right? So different organs. So that means blood is going to be purified by some of the organs, and after that blood will reach to the heart, because heart is the one that will going to pump the blood through to all the organs. What will be there? Of course, here we will going to have control unit, that is mind is the one which has a predefined algorithm, in fact the brain, and the brain channelizes the blood that comes from the heart to different organs, that may be legs, hands, or different parts of the body, right? Now once the legs gets the amount of liquid, that is blood, from the heart, then obviously you are able to run up to this load or walk up to this load, and then the mind will channelize the liquid to the hands, and then you are able to push the load, right? This is what exactly going to happen. Now have you understood one thing clearly here? To perform this particular task, you require the first thing blood, right? Of course. And then this part, whatever we are having here, kidney and liver, all these organs actually purifies the blood, and then heart will going to pump the blood, and then mind or brain, it will channelize the purified blood into legs and hands, right? So now actually if you combine all these things, suppose let me draw here, suppose if I fix all these things together up to here, now can anyone say what is the final aim here? The final aim here is we need to get either the linear displacement or angular displacement, right? So that means our final aim here is we need to push this load, or sometimes we may require to rotate the load. To do all these things, all these organs are participating in this particular task. All these organs together, it is actually called as actuation system. I hope you understood now clearly. All these parts together, it is called as actuation system. Clear? So that means I hope you understood that why we require answer to this particular question, why we require actuation system. Why we require actuation system? The final purpose of actuation system is to provide a linear displacement or angular displacement such that we can perform some work, right? Now the question is, what is actuation system? Obviously, because once you understand the question for why, what is very simple question, right? So all these devices or all these organs which are connected together forms a particular system to perform some particular work, right? So this chain of organs all together, it is called as actuation system. Now my question to all of you is, suppose let us say this is you and you are standing here, sorry, let us say you are standing here, you are standing here and you want to push 20 Newton load. 20 Newton is a small amount of load. A human being, moderately healthy person can easily displace this 20 Newton, right? Very good. Suppose if the load is 50 Newton, yes, of course you can do, because this is also not a huge amount of load. Now suppose, let us assume that in fact if it reaches to almost 1000 Newtons, right, then it's quite difficult, right? So maybe if I say instead of 1000, if I increase till somewhat higher than this number, suppose if I say 10,000 Newton I have, 10,000 Newton I have, and this is the load amount here, and you need to displace this particular load linearly or it may be angularly. Do you think that is it possible with the human beings? Definitely not, right? So whenever human beings are not able to do some action by themselves, then obviously we will take the help of the nature. So the readily available sources in the nature is, one is liquid, second one is air. Suppose if you take the help of the liquid to displace this particular load, then it forms the hydraulic actuation system. Suppose if you take air, if you take the help of the air to displace this particular load, then the system is actually called as a pneumatic actuation system. Now let me discuss all these things in detail. So as I said, actuation system is nothing but group of components connected together to perform required work by providing linear motion or angular motion forms the actuation system. This is exactly I told even earlier also, right? So even in the previous slide you have seen clearly that the final intention of all the organs working together is to displace the load, right? So same thing I have written in the script here. Now the components and elements available in actuation system streamlines the energy of any form such that it can be used to desired work properly. Clear? So that means whatever may be the form of energy, ultimately the energy should be streamlined to do some work. So now basically actuation systems are classified into two types. The very first thing is mechanical actuation system and the second one is electrical actuation system. Now when it comes to mechanical actuation system, again it is classified into two different types. One is hydraulic actuation system and the second one is pneumatic actuation system. It's very simple to understand. If you are taking the help of liquid, then it is called as a hydraulic actuation system. Suppose if you are taking the help of the air, then it will be called as a pneumatic actuation system. Suppose if you take the help of electrical power source, then it is called as electrical actuation system. It's quite simple. Now let me go into detail of each and every type of actuation system here, so that you all people will understand the things very clearly. Suppose let us look at the first one here, hydraulic actuation system here. Now if you look at the hydraulic actuation system altogether, it looks like this. So let me define first what it is. This type of system converts the liquid pressure energy into desirable form such that we can do some work. So that means the ultimate aim of hydraulic actuation system is to convert the liquid pressure energy back into a linear displacement or angular displacement, right? Now see the diagram here, you will understand this thing in better way. So you can easily understand in this particular diagram, we have the liquid source here. This is actually nothing but a liquid source. You can see here liquid source, or you can consider this as a reservoir. I mentioned this here, storage tank or reservoir. And what it will do, obviously this will be equipped with some amount of fluid, right, liquid. Most of the times we will use oil in hydraulic actuation system. I am not here to discuss what type of oil we are going to use, because that will come in the later sections, but we are going to use oil most of the times. So let me call that as a liquid for time being. So this is actually the tank or reservoir where the oil already stored, and we will use the filter here. So now let me compare these things with the human body. In case of human body, what was the filter we have to purify the blood? Obviously it's kidneys and livers, all those things, all those organs purified the blood. Similarly, even in hydraulic actuation system, to purify the liquid, first we need to have the filter. Filter removes all the dirt particles which are present in the liquid, and then pump will going to receive the liquid directly from the filter, purified liquid from the filter, and then it will stroke to the pressure regulator first. Now here comes the most important topic. What is pressure regulator and why we require pressure regulator? Suppose let us assume that this pump in a single stroke, if the pump delivers huge amount of pressure, then obviously it is very difficult to handle. That's why to manipulate the high pressure to the desirable pressure, we require actually pressure regulator. So pressure regulator regulates the quantity of the pressure of the fluid which is coming out of the pump. And then suppose if you have the excess fluid, then the excess fluid will be sent back to the tank. Here you can see this particular channel through which the excess fluid is again back to the tank. Now one more thing I want to tell you. Once the pressure regulator does its job, then obviously this liquid will enter into control valve. Because have you remembered in the previous example of the human body, I explained that the mind or the brain is the organ which actually channelizes the blood to different devices. Similarly, control valve or control unit is the one which accepts the pressure from the pressure regulator, and it will going to divert that fluid into the cylindrical chamber. Now you see in this particular cylindrical chamber, what we have here, we have a piston here. This is usually a circular piston because this is a cylinder. So the piston what we are going to use is actually a circular piston. Now the front view of this piston, it looks like this. It looks exactly like this. This is actually the piston, and it will going to have some circular area of cross section. As I said, this is the cylinder. Inside that we are having the piston, and this piston is connected to cylindrical rod again to this one. At the end we are having some weight load, and the final object here is we need to move this load either in the upward direction or we need to move this load in the downward direction. Now tell me what should happen here. The liquid, suppose if you see in this diagram, if the liquid enters here, then what will happen? Then the liquid will apply the pressure on the piston in downward direction. Then obviously this piston and cylindrical rod both will going to displace in the downward direction. Then the entire load will be displaced in the downward direction. Suppose if you want to move the liquid in upward direction, then what we need to do? The fluid should enter at the bottom, and this fluid now it will apply the pressure on the piston from below. Then obviously piston and cylindrical rod both will going to displace in the upward direction. Then the weight or the load will be displaced in the upward direction. This means that whether the load displaces in upward direction or downward direction, it purely depends on what? It depends on whether this control valve channelized the fluid flow above the piston or below the piston, right? So this mechanism, either it can be programmed or this mechanism can be handled manually. Both the ways you can do it. That means whether to select A port or B port, whether we want upward direct motion or downward direction motion, this can be done in two ways. One is either we can write the program for this or we can do it manually. Clear? So now if you look at all these things in a single point of view, then you might understood that this many components are working here for only single task, only single aim, single agenda. What is that? Either we should get linear displacement in the upward direction or we should get linear displacement in the downward direction. Clear? So as we are using liquid here, we used to call this particular actuation system as a hydraulic actuation system. Now let me quickly revise here. What are all the elements we used here? Obviously, if you want to use the liquid pressure energy, first thing you need to have the liquid. So that's what I have mentioned here. The first element should be storage tank or the reservoir where some fluid is available. And the second one is obviously filter is required, but filter is required if the liquid is not clean or if you have any dirt particles. Suppose if you are not having the dirt particles, if your fluid is really clean, then directly we can give the fluid or directly we can streamline the fluid to the pump, and the pump will stroke the fluid to the regulator, pressure regulator. What's pressure regulator? As I said, if you are having the very high pressure of the fluid which is coming out of the pump, pressure regulator it decreases that, and pressure regulator actually changes the quantity of the pressure that is coming from the pressure of the fluid that is coming from the pump. And then usually relief valve will do this action. Let me write down here. Relief valve acts like pressure regulator. And what is the next element here? Obviously next element is control valves, because you can see here control valve. Now have you identified this? So for this control valve we are having two output ports, right? This port A is, let me keep here, port A is connected to cylindrical cylinder but above the piston, and port B is actually connected below the piston, right? So two output ports are there, and if you see here control valve at the input side, one line is coming from the pressure regulator and another line is going to the tank. So whatever the excess amount of the fluid we are having, that will actually go this way. So how many channels are connected to the control valve? 4, right? So for this, let me explain about this one here, control valve, because this is one of the very important topic. So 4 channels are connected, that is from the pressure regulator to the tank as well as to above the piston, and second one is below the piston. 4 channels are connected and it can actually do two actions. What are those two actions? Either it can move the piston in the upward direction or it can move the piston in the downward direction. 4 by 2. Two actions it can do, 4 ports it has. So altogether it is actually called as 4 by 2 direction control valve. DCV means direction control valve. Means 4 ports it has and it can actually make two different actions. That's why it is called as 4 by 2 different direct control valve. So that is about this control valves concept. But you should remember this, the control valve can channelize the flow of the fluid either manually or it can be done by program. Both the ways it can be done. And the second thing, last one is actuator. And most of you might be waiting for this particular topic. Actuator. Now see, I explained about the tank and the pump and pressure regulator and control valve and filter. What is left now? Obviously the only one device which is left here is this one, correct? So let me keep here. The only one device which is left here is this total setup, right? This cylinder, piston and cylindrical rod, load and all these things, right? So this part, whatever we are having here up to here, that means cylinder, piston and cylindrical rod. All together this is called as hydraulic actuator. This is actually called hydraulic actuator. The final job of the hydraulic actuator is to convert the liquid pressure into linear displacement. Then it is called as a hydraulic cylinder. Suppose instead of x, if you are able to get theta as the output, if it is rotating, then that will be called as hydraulic motor. Let me write down here, that will be called as hydraulic motor. So this is all about hydraulic actuation system. I hope you understood this particular topic. Now let me go to the second kind of actuation system, that is pneumatic actuation system. Now let me show what are all the components we are having here. But before that, you need to understand what is pneumatic actuation system. It's very simple because you already know the previous two cases. One is human body and the second one is hydraulic actuation system. Pneumatic actuation system means altogether it's a system which converts air pressure into more suitable form which can be used to do the desired work. It is simple. Right? If you use a liquid, then it is called hydraulic actuation system. Now, if you want to use the air pressure to do some work, first what we require? Think and tell me. It is simple. First we require the air, supply of air, right? So but here the availability of air in the atmosphere is like it's very easy, right? So the air comes from the atmosphere. Now you see the diagram here. Air comes from the atmosphere, and the first device what we are going to have here is compressor, right? This compressor increases the pressure of the air that is coming from the atmosphere. Willfully we are going to do this action, and this compressor will be connected to the motor will be operated by some control signal, and when we turn on the motor, compressor will going to do its job, and it will going to compress the air to the desired pressure, and then it will be supplied to the second device, that is nothing but air receiver. Now have you remembered this? Previously when I was discussing about the hydraulic actuation system, we discussed like a regulator. Now, air receiver also do the same function like regulation, because when we are dealing with the pneumatic actuation system, we should be very conscious about the temperature, because the temperature of the air should not be changed too much. So we need to have our eye on the temperature. So this air receiver regulates the pressure of the air, and also it has the check on the temperature, whether the temperature is changing or not, whether what temperature it should be there. So all these things will be decided by air receiver, and once the air receiver does its job, then now the air will be sent into the directional control valve again. Now see how many ports we are having here. This particular directional control valve has one entry from the air receiver and one exit to the vent to the atmosphere. There in hydraulic actuation system, this exit is connected to the tank, but here it is actually allowed to go to the atmosphere because it's air, it can be flown to the atmosphere, right? Now this is one, and this is second. Now third one, this line is connected to above the piston. This is piston, this shaded portion is actually piston, and this is the fourth one, right? Now have you understood these things clearly? Here we are having 4 lines, and usually it will again perform 2 actions, because if the air is supplied to the port above the piston, then the air will going to push the piston in the downward direction. Then obviously the weight or the load will going to displace in the downward direction by an amount of x, right? Suppose if you allow the airflow from the downward direction, then it will going to apply the pressure in the upward direction, then the piston and the load both will get displaced in the upward direction. Now how many actions are done here? Again, control valve is able to make 2 different actions. That is, either it is able to displace the piston and cylindrical rod in the upward direction, or it can even displace in the downward direction. That's why again this particular control valve also called as 4x2 directional control valve, DCV, 4x2 directional control valve. Clear? Now let me come back to the whole system individually. I mean, what are the elements we used here? First thing what we used here, we used the compressor, right? So that's what I have written, motor driven compressor, because the purpose of the compressor is actually to increase the pressure of the air. Second thing, most of the students may get the doubt here whether we require the filters here or not. See, it is very easy to understand. If we are having the purified form, we don't require the filter. But if you are not having the purified form, either it might be air or liquid, in both the cases we actually required filter, right, to remove the air impurities. Now here, air receiver. What I said about air receiver is, air receiver I told you clearly that it is a regulator kind of mechanism it will do. The first thing, it will have the eye on the pressure which is coming from the compressor. Second thing, it will also have the eye on the temperature, whether the air is at a desired temperature or not, right? Because you all people might be knowing this fact that air gets air easily changes its temperature, right? So now the third one is control valve. What kind of control valve we used here? 4 by 2 directional control valve. And again, these control valves also can do its function in two ways. Either we can program the control valve, with the help of program we can run the control valve, or else manually we can control the control valve. Now the last one is pneumatic actuator. Now see here, as I said, even in this particular case, this one, whatever we have here, this part, this blue color part, completely it is called as pneumatic actuator. Why? Because this cylinder and piston and this cylindrical rod all together, it is taking the help of the air pressure to generate linear displacement. Clear? So similarly, suppose by chance if we get the angular displacement as the final output, then this will be called as a pneumatic motor. Pneumatic motor. Clear? So this is all about pneumatic actuation system. I hope you understood. Let us go to the third one. In fact, the last one is electrical actuation system. Now let me start from the basic again here. Electrical actuation system. Now by this time you guys should understand one thing. In every actuation system, we are taking the help of some form of energy and we are able to produce either linear displacement or angular displacement. Clear? Now in electrical actuation system, again we are going to take the electrical power source. That means we'll have a battery which is able to deliver the current to the motor, or else we will going to have the current source. Somehow we require some electrical power source, and naturally the electrical parameter like voltage or current, whatever we are getting out of the electrical power source, that will not be in purified form. That's why we require filters. Again, it may have some noise. So to remove the noise which is present in the voltage, we require to use the filter. And why regulator is required? See, it is as usually I said very clearly, the demand of the load may be something 4 milliampere current, but if electrical power source generate 40 milliampere, then the load cannot work. So regulator actually has the control on the level of the voltage. That means if you have more voltage, it will reduce, and if you have less voltage, it will going to maintain the voltage to the required level. Clear? So regulator does that job, and filter removes the noise, and then we will going to have, after the regulator and filter, we will going to have purified form of electrical output to the desired level. And then this particular value, as usually we are going to have control unit here. Control unit, either it can be programmed or it can be manually operated. What it do here is, because if you have, this is, let me say this is motor here, this is motor, you may have motor 1 here and then motor 2 here, like that 2 to 3 motors you might have. Then the supply or the electrical voltage or current, whatever we have here at this point, let me say here this is the voltage or current, but most probably this should be current. This should be current. Now the question comes here, this current should be supplied to which motor, whether motor 1 or motor 2. That will be decided by control unit. So control unit actually channelizes the current flow to the required load. It exactly functions the same way like how the brain works in human body. Correct? Because previously in the first slide I explained clearly whether to channelize the blood to legs or hands, that will be decided by the brain. Similarly, control unit decides whether to transfer this current to motor 1 or transfer this current to motor 2. Finally, the required amount of current in the purified form, it will come to the desired motor. Clear? And this current will enter into the coils of the motor, and the shaft of the motor will going to rotate. Clear? This is how electrical power can be finally converted into angular rotation. So if the electrical power is converted into angular rotation or the linear displacement, then that will be called as electrical actuation system. Clear? Now let me conclude this topic. What are the elements we used here? First thing, we used electrical power source. And the second thing is regulator and filters. Why the regulator and filter is required? Filter purifies the form, electrical form, and regulator changes the level. If there is any fluctuation in the voltage, regulator will going to keep the voltage at the required level even there is some fluctuation in the input side. That's the advantage of regulator. And after that we have control unit. Now what is the duty of control unit? Control unit channelizes the amount of current coming to it to the different amount of loads based on the importance, based on the priority, and based on the requirement. That is about completely related to the actuation system. Now you might understood there is some analogy between all kinds of actuation system, whether it is a human body, or it is a hydraulic actuation system, or it might be a pneumatic actuation system, or it might be an electrical actuation system. In all cases, some form of energy is getting converted into either linear displacement or angular displacement. First thing. Second thing is, in all four cases, we are having the energy source first, and then some purification and regulation is required, and then that should be channelized to the required load by control unit. So this is the whole theme of the actuation system. Now most of you by this time you might have some doubt, sir, if we have these three types of actuation systems, what exactly the merit and demerits of each and every actuation system? Now let me explain those things to you. So now you see by this time you might understood here. So now when it comes to the figure of merit, like merit and demerit, first thing, maintenance. In hydraulic actuation system, during installation, it takes more cost compared to other, because we need to buy many things that storage tank and many other things, right? But in the case of pneumatic actuation system, installation cost is slightly less, and electrical actuation system, it is very less. But unfortunately, operating maintenance will be high. Let us say operating maintenance, that means during the operation, when the actuation system is working, then operating maintenance is very high in pneumatic systems, very high, because the problem is when you are dealing with the air, two things are problematic. First is its temperature can change quickly. It is subjected to the changes of temperature. And the second thing is, if you transmit the air for long distance, then you will face so much of difficulty. So the very high maintenance is required, operational maintenance, and slightly less. That means let me write this as a high here. Okay, and electrical actuation system, compared to these two, it is less. Compared to both pneumatic actuation system as well as hydraulic actuation system, it is less. And the portability is also there, because you can take each and every device in your pocket and you can go somewhere, but you cannot take the tank and move to some other location, right? So it is as simple as that. Now the cost, as I said, operating cost is different and installing cost is different, but all together mechanical actuation systems, these both requires more investment, so of course the operating cost and initial investment, both if you together calculate, then we cannot judge very easily the mechanical actuation system. Sometimes it takes more amount for the pneumatic actuation system, sometimes it takes more amount for the hydraulic actuation system. But what we can do is the installing cost as well as operating cost together, we can compare with the electrical actuation system, that is here less. Clear? Compared to this hydraulic and pneumatic actuation system. Now the load quantity, that means how much amount of load we can displace angularly or linearly. So indirectly I'm saying, talking about the output power. Output power of hydraulic actuation system is very high. So let me write down this as very high, V high, and this part is high, that is pneumatic actuation system is slightly less compared to the hydraulic actuation system. And here when it comes to electrical actuation system, they are not capable to provide the output mechanical power which is almost equal to the hydraulic or pneumatic actuation system. Usually electrical actuation systems provides a very low output power. So by this time you should understand electrical actuators cannot displace 2000 newtons or 10,000 newtons and 20,000 newtons. Okay, now comes to the precision of the movement. Suppose if someone want to displace, just check here. Suppose let us say we are having here 2000 newton load, and if you want to displace this to 0.1 meter, if you want to displace this to 0.1 meter from the initial position, then this task can be done accurately by electrical actuation system. That means precision is very high, that means accuracy of the movement is very high for electrical actuation system. But when it comes to hydraulic and pneumatic actuation system, both are less compared to electrical actuation system. Do you know why? Because the problem is when you deal with the mechanical actuation systems, that is both this hydraulic and pneumatic actuation system together, these two are called as mechanical actuation systems, right? Both of these two, when you are dealing with the mechanical elements, you will have friction and like pressure variations, temperature variations, so many losses will be there. So it is obviously the accuracy of the design, accuracy of the required position you may not be able to reach properly. Clear? That is why I'm mentioning that electrical actuation systems provides a very high accuracy. And when it comes to operating losses, as I said earlier, operating losses because of the friction and the fluctuations in the temperature and all these things, operating losses will be very high here in mechanical actuation systems, but it is actually less in case of electrical actuation systems. Clear? So now by this time you should come to a conclusion that which is best. That I cannot generalize because it depends on your requirements. If you are really interested to displace heavy loads, then we require either hydraulic actuation system or pneumatic actuation system. But if you want to displace the object to some position accurately, then it's better to go for electrical actuation system. So I hope you understood this particular concept clearly. So in the upcoming sessions, I will going to explain about each and every element that present in what is it, like actuation system. That means every actuation system, suppose if you see hydraulic actuation system, what we are having control valve, regulator, filter and actuator and all these things, right? So in upcoming section, I will explain about each and every device in detailed way. So I request all of you guys stay connected to me, so you will understand the concept of actuators in upcoming sessions in very deeply. Thank you.